Okay, so today we're going to be working on section 9.4 of our matrices unit. We're going to be talking specifically about the properties of matrices, so commutative, associative, distributive, those kinds of properties, to see if they hold and test them out, see what's going on. We will also move into inverses and the identities, both additive and multiplicative. And so the additive being exceedingly easy and the multiplicative being much more complicated. So let's get started with our warm-up. So our warm-up is this one. So we're going to be practicing solving systems of equations with the three methods we currently know. The first one being graphing, then substitution, then elimination. We have in a few warm-ups recently been practicing solving for y in equations so we can quickly graph them. So that's how you're going to do graphing. We're not going to do any examples of that. Remember, you're looking for where the lines intersect, and they should intersect at a nice point. If they don't, then there's a problem. Substitution might require a little bit of refresh, so let's go ahead and take this second equation and solve it for y, giving me y equals negative 2x plus 10. And we're going to do substitution, so we're going to replace that into the first equation. So 5x minus 3 times y equals 3, and y we have just discovered is equal to negative 2x plus 10. And so then you can solve that equation, which I have no doubt that you can do quickly. As you're solving that equation, once you have x, go back and find y, because to solve a system of equations, you need both x and y. So that's the first step on part C. For part D, we will be using elimination. So we're going back to the original problem, and so we'll do it a little bit over here. We're going to take the second equation and times it by 3 so that y will eliminate. And so the first equation stays the same, 5x minus 3y equals 3. And the second equation becomes 6x plus 3y equals 30. So every single member of that didn't work the way I wanted it to, changes. And then to do elimination, you're going to add them together, and we're going to end up with 11x plus 0y equals 33. And of course, you can solve that. Once you know what x is, go back and find y. So go ahead and pause the video at this point and finish up this warm-up. And the answers will be here in a minute. Make sure you pause and do the work yourself. So you can see here in the graph, the purple graph is the second line. Y equals negative 2x plus 10, so y-intercept of 10, a slope of negative 2. The blue graph is the first equation, a y-intercept of negative 1, and a slope of 5/3, so of 5 over 3. And they meet at 3, 4. By substitution, I finished this problem. X was 3. I went back, I plugged into the second equation for this one and found y is 4. For elimination, I found x was 3, and I went, for variety's sake, into the first equation and found that y was 4. And so either way, the answer is 3, 4, and it's not that big of a deal. Moving on, so we're going to be talking again about properties of addition and multiplication. We're going to restrict ourselves to 2x2 matrices, and the only thing that we can assume as we are dealing with these problems is that they work for 2x2 matrices. We aren't showing it for anything else. We're not going to be showing it for always, and it's important to know that for the most part, these things tend to work for square matrices and not for others. That really holds for matrix multiplication, since we have to have the number of columns match the number of rows. So the number of columns in the first matrix match the number of rows. And so that gets complicated for commutative properties, etc. But for square, it works out because the dimensions are the same. So we're going to start with the associative property, which basically means I can add in any order I want. You're going to pick random numbers for your matrices, and for this one you'll need 3. 1, 2, 3, 4. You can make them negative or positive. I find that I'm more convinced when I use a variety, and I'm just trying to convince myself of what's going on here. There's very little space, so do your best. But basically we're saying, hey, can I add in any order I want? You can use the exact same matrices for down here, or can I multiply in any order I want? and see if it makes any difference if you go the first two times the second one or the second two times the first. That's the idea. I'll do a quick one with numbers. Let's say I had 5 times 7 times negative 3. 5 times 7 is 35 times negative 3 is 90 plus 15, so 1 whole 5 negative. And then we'll try it again with 5 times 7 times negative 3 that way, which is 5 times negative 21, which is negative 105. And so that is clearly true. We already knew that. And for addition, same numbers. 5 plus 7 plus negative 3, which is 12, plus negative 3, which is 9. Is that the same as 5 plus 7 plus negative 3, parentheses here, which is 5 plus 4, which is 9. So yay for math. And you're going to be trying this with matrices. So we talked about this briefly in class and did the distributive property together. So you're going to do the associative property at addition and multiplication, and then the commutative property. So let's go ahead and try the commutative property of matrix multiplication. We'll use 1, 2, 3, 4. Make my 4 negative and my 1 negative. And then for my second matrix, I will use 5, 6, 7, 8, because I'm so fancy in my number choices. And we'll make these negative over here just for the sake of having variety. And we will try to see if this is the same as this one. So I will do one and leave you to do the other. Negative 7, 8, and then negative 1, 2, 3, and negative 4. What we're trying to decide is if it's the same if I switch them. So we recall that we're going to take this row and times it by this column and times it by that row. So 1 times, never mind, that's backwards, this times this. So negative 5 and negative 14. And then this one, positive 6 and plus 16. Then we have this one times that, which is 15 plus 28. And for the other one, negative 18 minus 32. And so that becomes, let's get a rectangle over here. And that becomes negative 19 that way. Negative 19, 22, 30 plus 13, which is 33, and 50, negative 50. Please double check that I did that right by using a calculator to back that up, and then try this one and see if it's the same. So that's the idea. Addition is much easier. Notice I haven't done an addition example, and that's on purpose. Addition is much easier, and hopefully you recorded our distributive property conversation from the other day. If not, that one's a little bit harder. This one was true. The fact that distribution holds makes me believe the others do, but they don't always, and so it's important to check them. And then when you're done, that's the end of this video. We will continue with inverses and identities on the next video. I'll see you soon.